Hello students, this is the question from JEE Advanced 2026 on chapter chemical equilibrium, and it is a very easy level question and it has four graphs. You can see the graphs. Look at the graphs carefully. I will read out the question. For a reversible reaction R giving P at constant temperature, both the forward and backward reactions are first order elementary reactions with rate constants Kf and Kb respectively. At time 0, the concentration of R is R0 and concentration of P is 0. So there is no P initially. At any given time, R and P are the concentrations of R and P respectively. So if Kb is equal to 4 times Kf, the correct graphical representation of reaction is, so this is a reversible reaction, R giving, reactant giving product, and it is first order in both R and P. So we have, and what is given for forward reaction, rate constant is Kf, and for backward reaction, rate constant is Kb. So we have Kc of reaction. You must know this simple formula. Kc is Kf by Kb, and Kc for this reaction or equilibrium is concentration of P divided by concentration of R. So it is given in the question, value of Kb is 4 times Kb is 4 times Kf. So we have Kc is equal to Kf divided by 4 Kf. It is Kf divided by 4 Kf. So this value is 1 by 4. So we have Kc is equal to, so the concentration, final concentration at equilibrium for P and R. So concentration of R should be 4 times, or I can write it as concentration of R at equilibrium is equal to concentration of 4 times concentration of P. So at equilibrium, what we have to check at equilibrium? We have to check that the concentration of reactant should become 4 times that of product. And at equilibrium, the concentrations becomes, so initially we don't have any product, concentration of product is 0, and initially we have some amount of reactant whose concentration is R0. It will decrease and it will increase, but we have to check at equilibrium which concentration is greater. For reactant, its concentration is 4 times that of product. So concentration of reactant should decrease, but it should be 4 times that of concentration of products. So looking at 4 graphs, in first A graph, we have concentration of, at equilibrium, we have concentration of R is equal to concentration of P. Then for this first option, Kc will be 1, but we have Kc is equal to 1 by 4. So first option is wrong. Let's check second B option. In B option, finally the concentration of P is 0.8 and that of R is 0.2. So in B option we have concentration of product is 0.8 and that of reactant is 0.2. So here if we find the value of Kc, it will be concentration of product 0.8 divided by concentration of reactant 0.2. It is coming out to be 4, and hence B option is also wrong. In A option we have concentration of product is equal to concentration of reactant. So Kc will be 1. So this option is also wrong. And in C option we have concentration of reactant. Final concentration of reactant at equilibrium is 0.8 8. Concentration of reactant is 0.8 and that of product is 0.2. So value of Kc will be concentration of product 0.2 divided by concentration of reactant 0.8. So this value is coming out to be 1 by 4. So this option is matching with here the value of Kc calculated from this ratio. So we want Kc should be equal to 1 by 4. So correct answer is C option. In D option, the concentration of reactant is continuously decreasing and that of product is continuously increasing. So at equilibrium, the concentration should be constant. It is not changing. So option D is obviously wrong. So correct option is C. You have to just check the Kc of reaction should match with this final result. Kc is equal to concentration of product by concentration of reactant at equilibrium. That's it. It is a very easy question. If you do not solve in this way, you can observe the graph within 5 to 10 seconds and check whether the value of Kc is matching or not. That's it. Thank you.